Great, kids. Now, for this last part of the lesson, we're going to apply certain properties of parallelograms, the four properties of parallelograms, into algebraic problems. The last problem is going to be a proof. So, for the first problems, I am expecting that it's going to be very easy for you. Great. So, here, I want to find in the first set of parallelograms, I have all of these are parallelograms, and I want to find the missing angles. So, angle X is very clear that it's 65. Why? Because 65 and angle X are corresponding angles, because remember that these lines are parallel. Now, angle Y is also 65, because in a parallelogram, opposite angles are congruent. And now, C is 180 minus 65, because in a parallelogram, consecutive angles are supplementary. So 180 minus 65, that is 125 degrees. Beautiful. Now, again, look at the parallel lines. The parallel lines, the C's, are the ones that are going to help you. So, for example, angle X, without doing any math, very quickly, X equals to 56 degrees. Why? Because these are opposite angles, and opposite angles in a parallelogram are congruent. Then we know that if this is 56, whatever Y measures is we know that Y plus 85 plus 56 is 180. Because we know that this plus this is 180, because consecutive angles in a parallelogram are supplementary. So Y equals to 180 minus 85 minus 56, that is 39. Beautiful. Then we could find out C by doing, if we know that this one is 39, we can find out C by using this triangle, no? So that is 180 minus 39 minus 56. So C is 85. Excellent. Because I am using this triangle, right? Beautiful. In this one, without doing any math, very immediately, X equals to 110. Why? Because they are vertically opposite angles. Then C equals to 70. Why? Because these lines are parallel. Then Y, well, Y is 40. What? How? Because I know that if in this triangle, the exterior angle measures 110, so this angle and this angle add up to 110, so 110 minus 70 is 40 by the exterior angle theorem. Excellent. Now we're going to find both sides and angles. So if this angle measures, if this side measures 8, this side also measures 8. And if this side measures 15, then this side also measures 15, because in a parallelogram, opposite sides of a parallelogram are congruent. Beautiful. So if this measures 80, this one also measures 80, because opposite angles in a parallelogram are congruent. And now this plus 30 plus 80 equals to 180. So 180 minus 30 minus 80, that is 70, because I am doing that this plus this is 180. Lovely. Now, look, if this measures 9, this also measures 9, because diagonals bisect. If this measures 11, then this one also measures 11. If this measures 33, then this measures 33, because alternate interior angles are congruent. Then what else they are asking us for? Y. So this angle measures, oh my god, 103. And this one measures 50 plus y, and we know that 103 plus 50 plus y is 180. So y equals to 180 minus 153. So that is 27. Beautiful. Excellent. Now look, this is a parallelogram, but not any parallelogram. This is a rectangle because I have a right angle here. So because this is a rectangle, I know that all of this are right angles. So immediately x equals to 90 degrees. Also in parallelograms, opposite sides are congruent. So A measures 10. Lovely. Now, this is a triangle that measures 45 and 45, right? Because angles need to add up to 180. And now, what is the measurement of this side? We need to find it because we need to find the measurement of B. Well, what type of triangle is this triangle? It's a triangle that has a set of two congruent angles. And a triangle that has two congruent angles is called an isosceles triangle. And in an isosceles triangle, two sides are congruent. So this measures 4 and this measures 4. So B measures 4. Ka-choom, pow. Beautiful. Now, every quadrilateral here is a parallelogram. And again, we're going to be doing some math kids. I want you to be very careful with this. Because again, here I have systems of equations. Here I have systems of equations that involve quadratics. And you know something? We are maniacs. We love systems of equations and we love quadratics. So if you expect to see something in the test, you wouldn't be expecting to see something like this, that it's an easy dubs problem. No, no, no. You're expecting to see something like this, that it's like a what? Okay, so let us get there. This angle measures 42, and this angle measures 8x minus 6. So we can find x or y first. We're going to find x first. We know that consecutive angles in a parallelogram are supplementary. So this 2 should add up to 180. So 8x equals to 180 plus 6 minus 42. So that is 144. So x equals to 144 divided by 8. So x equals to 18. Lovely. Then this and this are opposite. And what do we know about opposite angles in a parallelogram? Opposite angles in a parallelogram are congruent. So 3y equals to 42. So y equals to 42 divided by 3. And 42 divided by 3, it's an easy 14. Lovely. Now I have the diagonals of a parallelogram. The diagonals of a parallelogram bisect. That means that this and this are the same, and this are the same. So 3x plus 4 is the same as 25. So 3x equals to 21, x equals to 7. 2y minus 8 equals to 28. So 2y equals to 36. So y equals to 36 divided by 2, and that is 18. Lovely. Okay, oof. This is getting harder. I can feel it. This angle, 35, measures the same as 6y plus 5. 35 equals to 6y plus 5. So 30 equals to 6y. So 5 equals to y. Beautiful. And now look at this one. We have a triangle here. So, oh my gosh, I erased the triangle. We have a triangle here. So 80 plus 35 plus 5x equals to 180. So 180 minus 80 minus 35, that is 65. So 5x equals to 65, and 65 divided by 5, that is 13. So those are my solutions for this problem. It's getting harder, I can feel it. Beautiful. Now, okay, great. Now for the next one, so this is a harder problem. Please observe that here you have an angle of 130. Also, please observe that here and here you have angles of 50 and 50. So please, first of all, I want you to look at this triangle. So this triangle, this angle, whoopsie, it's x minus y, and this angle is x plus y. So in this triangle, we have x minus y plus x plus y plus 50 equals to 180. So we have y's cancel out, so that is 2x plus 50 equals to 180. So 2x equals to 130, so x equals to 65. And that's lovely. Okay, now please look at this. This angle, the angle x minus y, is alternate interior to this one, right? This is x minus y. And now I want you to look at this triangle. So in this triangle, we have 85 plus 50 plus x minus y. So plus 65 minus y equals to 180. So we have we can solve for y now. So we just have to do 180 minus 85 minus 50 minus 65. So minus y equals to minus 20, so y equals to 20. Kids, this was a very hard problem, okay? Excellent. We're almost done with the algebraic problems. Okay, so now again we have a parallelogram, and maybe you want to say like, oh my god, this is a triangle, but it is not. Sorry, it is a square, but it is not. We don't know it. So look, we know that this and this are the same, and we know that this and this are the same. So we know, I'm going to put it in the same color, like this and this. 2x plus 2y is the same as 18, and 2x plus 5y equals to 30. Now, there are so many ways in which we can solve this system of equations with two variables. But I think that one is being asked to, is like screaming, no? Like the problem is screaming, use elimination. Because if you use elimination, look, if you subtract, it would be the two x's cancel out, so it is 0 minus 3y equals to 12, to negative 12. So y equals to 4, and that is lovely. Now you plug it into an equation, so that is 2x plus 2 times 4 equals to 18. So 2x plus 8 equals to 18. So 2x equals to 10. So x equals to 5. And that is the solution of this problem. Beautiful. Now this one is a hard one. This one, the hardness of this problem was that you need to know how to solve a system of equations. And that you need to be fluent in elimination, because if you don't want to use elimination, that's okay, that's on you. If you want to do something like substitution, it's okay, but you don't have to. If you want to do something like graphing the lines, then you are cray-cray, but it's okay. Like, we respect your preferred ways of solving a system of linear equations. The last one, again, we have diagonals being bisected. So this is the same as this, and this is the same as this. Let me put it with colors. So x equals to 3x minus 40, and y squared equals to y plus 30. So very nicely, this is not a system of equations because the equations are independent, are uncoupled. So like I just have to like subtract x from both sides, add 40, so 40 equals to 2x, x equals to 20. And now here I have a quadratic. Now there are so many different ways of solving a quadratic equations. You may prefer the quadratic formula by factoring, by drawing a parabola. We're gonna do it by factoring because we are factoring fans. In any method, the first thing that you have to do is make it equal to 0. Now we need to find two numbers that add to the one in the middle, that add to -1, and that multiply to -30. So I'm gonna think about those numbers. So numbers that multiply to 30, 30 times 1, 15 times 2, 3 times 10, useless because it was 29, 31, 17, 13, 13, 7, 30 is not divisible by 4, where 30 is divisible by 9, sorry, by 5, so that is, oh my gosh, sorry, this is just talk, by 5, so that is 6 times 5, and 6 times 5, if I do -6, +5, those numbers work. So this is the same as y minus 6 times y plus 5. So my two solutions are y equals to 6 and y equals to -5. But I have a question for you kids. No, I have no question for you. These two are answers. Beautiful. Congrats. Excellent. Let's move on. Okay, so the next problem is a graphing problem. This problem will remind us things that we learned in the last semester. So, okay, let us start by graphing the points of this shape, this quadrilateral. So P is in 2 in x, 6 in y. So here I have P. Q is in 9, 9, 9 in x, 9 in y. O is at the origin, and R is in 7, 3. Lovely. So this shape, here is Q, here is R. So this shape is a certain shape. Now OQ and PR, I'm going to use another color. OQ is a diagonal and PR is the other diagonal. So what is the midpoint formula? Remember that the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So the midpoint of OQ is going to be applying this to O and Q. So it is 9 plus 0 divided by 2, 9 plus 0 divided by 2. So that is the 4.5, 4.5. This is the midpoint of OQ. Lovely. Then the midpoint of PR is applying this formula to P and R. So it is 2 plus 7 over 2, 6 plus 3 over 2. And that is 9 halves and 9 halves. So that is again 4.5, 4.5. So yes, they do have the same midpoint. Now, because they have the same midpoint, that means that this and this are the same, and this and this are the same. So this is a parallelogram. Then let us find the slopes. So what would be, I'm going to use another color, I'm going to use a crazy green. What would be the slope from going no, I said green and then I choose yellow and then I hated yellow. I'm going to choose this flamingo. So the slope of OR is rise over run. So I have a run of 7 and a rise of 3. So the slope of OR is a rise 3 over run 7. Then the slope of PQ, please observe that it is from 2 to 9, so it is a run of 7 and a rise of 3. So the slope of PQ is 3 over 7. The slope of PO, is a run of 2 and a rise of 6, rise over run. And the slope of RQ, oh my gosh, so many drawings in this diagram. The slope of RQ is 6 over 2. Excellent. So it is indeed a parallelogram. Now let us go for the last part of this problem, this 2-column proof. Okay, so we're going to start this problem by drawing our table of statements and reasons. Maybe if we do a plan first. So we know that PQRS is a parallelogram. So PQRS, this is a parallelogram. So that gives us so many information. Like we know that PQ and SR are parallel, SP and RQ are parallel, SR and PQ are congruent, SP and RQ are congruent. We know that angle P and angle R are congruent, angle P and angle S are supplementary. We have so much information. Okay, additionally to this, it is given to us that this thing, PJ, like the thing you wear to sleep, a PJ, and KR, like the thing you drive, a car, are congruent. And we want to show that angle 1 and angle 2 are congruent. So the first thing that you need to look for is for a couple of triangles to be congruent. So I believe that these two triangles want to be congruent. How would you argue that these two triangles are congruent? Well, a way of arguing this would be, for example, if we say that, okay, if you look at the triangles, what do they have in common? What do we know is congruent among these two triangles? We know that this and this is congruent because it is given. We know that this and this is congruent. Well, they are congruent because they are opposite sides of a parallelogram. And then we know that P and R are congruent because they are opposite angles in a parallelogram. Finally, angle 1 and angle 2 are corresponding angles, corresponding parts of congruent triangles, so they are congruent. So that is our plan, to prove that SPJ and QRK are congruent. Beautiful. So, statements and reasons. I think that I prefer how the pen looks now. It's beautiful. Okay, so I'm not going to write the givens. Well, I'm just going to put that PJ and RK are congruent, given. No, the parallelogram thing, I'm not going to write it. Now, then SP and RQ are congruent because opposite sides in parallelogram, I'm just going to draw a little parallelogram. In a parallelogram are congruent. So now we know that this and this are congruent, and this are congruent. Then angle P and angle R are congruent because opposite angles in a parallelogram are congruent. Then we know that triangle, I'm gonna write PJS is congruent to triangle RKQ because of a side angle side. And then finally, angle PJS is congruent to angle RKQ because of CPCTC. Beautiful. Angle 1 is congruent to angle 2. I hope that you have enjoyed this lesson as much as I did.